Welcome to JS Tuitions. So in physics we're going to start the topic referred to as wave motion. So a wave is defined as a disturbance from one point to another that transmits energy. It is referred to as a disturbance from one point to another that transmits energy. And there are two types of waves. We have the transverse wave and the longitudinal wave. So let me just write these points on the whiteboard. So I've said the definition of the wave. A wave is a disturbance from one point to another that transmits energy. Then I've said there are two types of waves. We have the transverse wave and the longitudinal wave. So the two types, we have the transverse and the longitudinal wave. So we start by talking about the transverse wave. So what is a transverse wave? A transverse wave is defined as a type of a wave where the vibration of the particles are at right angle to the direction of the travel of the wave. So it is defined as a type of wave where the vibration of the particles are at right angle to the direction of the travel of the wave. And the types of transverse wave, we have the light waves and the water waves. Those are the two examples of the transverse waves. So this is a type of a wave where the vibration of particles are at right angle to the direction of the travel of the wave. Then I've given two examples of the transverse wave. I've said light and the water waves. So examples, we have the light and water waves. Let us now look at the structure of the transverse wave. So I'm going to draw the structure of the transverse wave. So as you can see, this is the structure of the transverse wave, and this arrow just shows the direction of the wave. So this part is referred to as the displacement. This arrow represents the displacement. Then this arrow, the point from here to here, is referred to as the amplitude. Then the dotted line is referred to as the rest position, then the upper part of the wave here is referred to as the crest. The lower part is referred to as the trough. Then the distance between two successive crests. So as you can see, I have the crest here, I also have the crest there. So that distance is referred to as a wavelength. Then this part, the part that I've drawn in black, this represents one wave. So this is one wave. So let us look at the definitions of the parts that forms the transverse wave. So the first part, we have the rest position. So the rest position, this is the region where there is no vibration of particles. So this line, as you can see, this line, it shows that the particles here, they don't vibrate. So that's the rest position. Then 2, I have the displacement. So the displacement shows the direction, and it shows the distance and the direction of the particles from the rest position. So it just shows the distance and the direction of the particles from the rest position. Then I have the crest. So the crest, which is this part, the crest is defined as the highest point of the wave. So the crest is just the highest point of the wave. Then I have the trough here. The trough is defined as the lowest part of the wave. As you can see, my trough is here. So this part, this part, this part may form the troughs. Then the other way that I have on this diagram, I have the amplitude. So the amplitude is defined as the maximum displacement of the particle from its resting position. It's the maximum displacement of the particle from its rest position. That's the amplitude. Then I also have the wavelength. This part here. So the part from here to here. So wavelength. So the wavelength is defined as the distance between two successive troughs. Is defined as the distance between two successive troughs or two successive crests. And from the diagram, I used my crest, this part and this part. But in other books, the wavelength is defined as the distance in which a wave repeats itself. The distance in which a wave repeats itself. So we are going to proceed. The next thing that we're going to talk about is the longitudinal wave. The next thing that we're going to talk about is the longitudinal waves. So longitudinal waves are types of waves where the vibration of the particles are parallel to the direction of the travel of the waves. So they're defined as the types of waves where the vibration of particles are parallel to the direction of the travel of the waves. And the types of longitudinal waves, we have the sound waves and the spring waves. So let me just write this definition on the board. So the longitudinal waves, these are types of waves where the vibration of a particle is parallel to the direction of the travel of the wave. Then examples of longitudinal waves, we have examples of longitudinal waves. I've said the sound waves and the spring waves. So sound waves and spring waves. Let us now look at the structure of the longitudinal wave. So the longitudinal wave is drawn like this. So this is the structure of the longitudinal wave. So as you can see, this region is referred to as the rarefaction. Then this part is referred to as the compression. Then the distance from here to here is referred to as the wavelength. So let's look at the definitions of these words. So the first word I have the wavelength. So the wavelength is defined as the distance between two successive rarefactions. So as you can see, we have a rarefaction here and a rarefaction. So it's the distance between two successive rarefaction. Then what about the word rarefaction? So rarefaction, this is a region where the particles are not close together, the particles are pulled apart. So this is where the region, this is the region where particles are pulled apart. Then we also have the compression. The compression is defined as the region where the particles are closer together. So the region where particles So next time we are going to proceed on wavelength. Thank you very much. So today in wave motion we are going to proceed. We are going to look at the characteristics of waves. And last time we defined what waves are, and we talked about two types of waves. We said that two types of waves, we have transverse waves and longitudinal waves. So today we are going to proceed. We are going to look at the characteristics of waves. So waves that are produced by a continuous vibrating object are referred to as periodic waves. And these periodic waves, they have the amplitude, the wavelength, the frequency, and the period. So periodic waves, they have the amplitude, the period, the frequency, and the wavelength. So what is the wavelength? The wavelength is defined as the minimum distance at which a wave repeats itself, and wavelength is measured in meters. And the symbol for wavelength is lambda, which is a Greek letter. Then we're going to go to the amplitude. So what's the amplitude? The amplitude is defined as the maximum displacement of the particle from its rest position. And amplitude is represented by the symbol A. Then going to frequency. So what's frequency? Frequency is defined as the number of waves that are passing through a certain point per second. So these are number of waves that are passing through a certain point per second. And frequency is measured in Hertz, and this is H and Z. And the symbol of frequency is F. Then we go to the next one, which is period. So what's period? Period is defined as the time taken for one complete wave to be formed. And the symbol of period is capital letter T. And period is also defined as the inverse of frequency. So when calculating period, you can say period is equals to 1 divided by frequency. So let me just write these notes on the whiteboard. So I've said waves that are produced by a continuous vibrating object are referred to as periodic waves. So waves that are produced by a continuously vibrating are referred to as periodic waves. And these periodic waves, they have the amplitude, wavelength, frequency, and period. So the periodic waves they have the wavelength, the amplitude, the frequency, and period. So we start with the amplitude. So the amplitude is defined as the maximum displacement of a particle from its rest position, and the symbol of amplitude is capital letter A. So this is the maximum displacement of a particle. From its rest position, and the symbol of amplitude is A. So the symbol of amplitude is capital letter A. So capital A. We go to wavelength. So what's the definition of wavelength? Wavelength is defined as the maximum distance at which a wave repeats itself, and The symbol of wavelength is a Greek letter which is lambda, and wavelength is measured in meters. So wavelength is the minimum. This is the minimum distance at which a wave repeats itself. Then the symbol of wavelength is a Greek letter which is lambda. So lambda is given like this. This is the symbol of lambda, and the units of wavelength are meters. So wavelength is measured in meters. Is measured in meters. We proceed. We look at frequency. So frequency is defined as the number of waves that are passing through a certain point per second. And the symbol of frequency is capital letter F, and frequency is measured in Hz, which is Hz. So frequency are number of waves passing through a certain point per second. Then frequency is measured in Hz. And the symbol of Hz is capital letter Z, a capital letter H, and the Z. Then the symbol of frequency is F. So the symbol of frequency is F. Then the formula that you use when calculating frequency, say F is equals to number of cycles divided by time. So number of cycles divided by time. So this is the formula that you use. We go to period. So period is defined as the time taken to produce one wave, and period is measured in second. And the symbol of period is capital letter T. So period is defined as, this is time taken to produce one wave, and period is measured in seconds. So period is measured in seconds. And the symbol of period is capital letter T. The symbol so capital T. And you can also say period is the inverse of frequency. So period is the inverse of frequency. So the formula that we use when calculating period, we say capital letter T is equals to time divided by number of cycles so we can also say T is equals to 1 divided by F. So another wave characteristic that we're going to talk about is speed. So speed is defined as the distance traveled by a particle from its rest position per second. The distance traveled by a particle from its rest position per second. And the symbol that is used to represent speed is capital letter V, and speed is measured in meter per second. And the formula that you use when calculating speed, you say V is equals to frequency multiplied by wavelength. So I'm going to write these notes on the board. So I've said speed is distance. So speed is distance traveled by a particle per second, and speed is represented by the symbol V. So speed is represented by capital letter V. So capital V. Then the symbol of speed is meter per second. The units of speed is meter per second. And the formula that you use when calculating speed, you say V is equals to frequency multiplied by wavelength. And since we know that the symbol of frequency is F and the symbol of wavelength is lambda, so you say V is equals to F multiplied by lambda. So this is the formula that you use. So today in wave motion, we're going to look at an example. So I've already written this example and we're going to go through this example. So we're going to calculate the wavelength, the speed, the frequency, and the amplitude of this example. So the example reads, the distance from the start to the end of the wave train in the diagram is 30 centimeters, and the distance from the crest to the trough is 8 centimeters. The whole wave train moves past a fixed point in 20 seconds. Then question A reads, how many waves are there in this wave train? That's the first question. Question B, calculate the following. Roman numeral 1, wavelength. Roman numeral 2, amplitude. Roman numeral 3, frequency. Roman numeral 4, speed. So I'll start with the first one. How you can calculate the number of waves. So that's A. So my first question says, how many waves are there in this wave train? So as you can see, this is my diagram. And I know that the definition of wavelength is the minimum distance at which a wave repeats itself. So I'll start counting. So from here to here, that's 1, 2, 3, 4, 5, 6. So I have 6 waves. So this is 6 waves. Then B, Roman numeral 1. The question reads, calculate the following wavelength. That's my first question. So I'm supposed to calculate wavelength. Then I know that the distance that the train travels is 30 centimeters. Then I have 6 waves. So I need to calculate the wavelength. So wavelength, I know that the symbol of wavelength is lambda is equal to, so I'll say 30 centimeters divided by the number of waves, which is 6. And this is giving me, so 30 divided by 6. 30 divided by 6 is giving me 5 centimeters. Then since the units of wavelength is meters, I'm going to divide this 5 by 100. So I'll say 5 divided by 100. I'm having 0.05 meters. So this is the wavelength. Let us proceed. Let us look at Roman numeral 2, which is the amplitude. So Roman numeral 2, I'm supposed to calculate the amplitude. So the amplitude is the distance from here to here. Then I know that the distance from the trough to the crest is 8 centimeters. So this means the distance from here to here, that's 4 centimeters. So amplitude is 4 centimeters. And I know that amplitude is measured in meters. So I'll divide 4 by 100. And that's giving me 0.04 meters. Then let us calculate the frequency. So this is Roman numeral 3. So frequency is given by the formula number of waves over time. So my number of waves, I know that I have 6 waves. So 6 divided by the time. The time that the train takes. Let us read the question. The whole wave train moves past a fixed point in 20 seconds. So it is 20 seconds. So 20. So 6 divided by 20. That's 0.3 hertz. What about Roman numeral 3? I'm supposed to calculate speed. So I know that the formula of speed is V is equals to frequency multiplied by wavelength. So my frequency is 0.3 multiplied by the wavelength is 0.05. So my speed is equal to 0.3 multiplied by 0.05. It's 0.015 meter per second. So this is how you can calculate this question.
JS online tuitions are available each and every month, and we provide the following subjects: mathematics, biology, physics, chemistry, and accounts. The price is only 100 kwacha per subject, and that's per month. For further information, you can call me on these numbers: 0973 02 36 20 or 0964 28 69 13, or you can text me on WhatsApp or on Telegram on 0973 02 36 20. Join the online tuitions today and have a real life change with your education. I'll be hoping to see you soon. God bless.
So the next thing that we're going to talk about is the electromagnetic spectrum. So the electromagnetic spectrum consists of waves that have different wavelengths. So this starts from the radio waves to the gamma rays. And some of the electromagnetic waves that we use in our daily lives include the radio waves, the microwaves, and the infrared. Then the X-rays and the gamma rays, they also form part of the electromagnetic spectrum. And how the sequence is arranged, we have the radio waves, the microwaves, the infrared radiation, the visible light, the ultraviolet waves, we have the X-rays, we also have the gamma rays. So let me just write these points down. So I've said the electromagnetic spectrum consists of waves that have different wavelength. Then some of the electromagnetic waves that we use in our daily lives include the radio waves, the microwaves, and the infrared. So some of the electromagnetic waves that we use in our daily lives include the radio waves, the microwaves, and etc. Then the sequence. So this is how the sequence is. So as I'll draw, these are representing the wavelength. So the radio waves, they have their wavelength is large. As you can see, their wavelength is large. Then coming after the radio waves, we have the microwaves. Then the wavelength of the microwaves is also large, but it's not larger than those of the radio waves. Then we have the infrared radiation. So also these, they have a large size of the wavelength, but their wavelength is less than that of the microwaves and the radio waves. Then we also have the visible light. We have ultraviolet waves. Then we have the X-rays and the gamma rays. So moving from left to the right side here, the wavelength is reducing while the frequency is increasing. So the frequency is increasing. Then let us now look at the length of the wavelength. So the electromagnetic waves that have a short wavelength we have the gamma rays. And the source of the gamma rays is nuclear radiation. So nuclear radiation. We also have the X-rays. And the source of the X-rays is explosions. Then the wavelength are the electromagnetic waves that have a medium wavelength. We have the ultraviolet. So the source of the ultraviolet, they come from hot objects. So hot objects. These include the sun and the sparks. So the sun and sparks. Then we also have the visible light. The source of the visible light, we have hot objects. So this includes the sun. Then the other electromagnetic wave that has a medium wavelength, we have the infrared radiation. Infrared radiation. And the source of the infrared radiation, we have hot objects. So hot objects, one of them is the sun. Then we come to the microwaves and the radio waves that have a large wavelength. So those that have a large wavelength, we have the microwaves and the radio waves. So the microwaves and the radio waves. So the microwaves, they come from short transmitters. So these transmitters include those that transmit signals for the cell phones. So these, they come from short transmitters. Then the source of radio waves, they come from the transmitters of radio and TV. So transmitters of radio and TV. So the next thing that we are going to talk about are the characteristics of the electromagnetic spectrum. So the next thing that we're going to talk about are the characteristics of electromagnetic waves. So the first characteristic is that all electromagnetic waves are transverse waves. The second characteristic is that all the electromagnetic waves, they are able to pass through vacuum. The other characteristic is that all electromagnetic waves are made up of pure energy. And the other characteristic is that these electromagnetic waves, they travel at a speed of light, which is 3 multiplied by 10 to the power 8 meter per second. So these are the characteristics of electromagnetic waves. Then the other thing that we're going to talk about is how these electromagnetic waves differ. So the thing that you need to know is that when the wavelength is large, that means that the frequency is going to be small. So when the wavelength is large, that means the frequency is going to be small. Then the other thing that you're supposed to know is that when the wavelength is small, that means that electromagnetic wave has a high energy. And when an electromagnetic wave has a high energy, that means that its penetrating power is very high. So the smaller the wavelength, the higher the penetrating energy. Then the other thing that we're going to talk about are the instruments that are used to detect these electromagnetic waves. So we'll start with the gamma rays. So the gamma rays are detected by the Giga-Mura counter. Then the X-rays that are detected by the photographic films. Then the ultraviolet that are detected by the photographic films. Then the infrared are detected by the skin. Yeah, they're detected by the skin. Then the microwaves are detected by the aerials and the satellite. They're also detected by a container that contains water in it. Then the radio waves are detected by the areas that have a TV or a radio set. Then the other thing that we are going to talk about are the harmful effect of the electromagnetic waves. So one of the harmful effects is that they cause skin burns. That's one of the harmful effects. The other harmful effect is that they cause cancer. Then the other harmful effects is that they cause mutation to the cells. So these are the harmful effects. So let me just write down what I've said. So the first thing that we're going to talk about are the properties or characteristics of these electromagnetic waves. So I've said the first characteristic is that they are transverse waves. So they are transverse waves. So all electromagnetic waves are transverse. Then the other characteristic is that they are able to pass through vacuum. They are able to pass through vacuum. Then the other characteristic is that they have a speed of light, which is, so they have a speed of light, which is 3.0 multiplied by 10 to the power 8 meter per second. Then the other characteristic is that they are made up of pure energy. So they are made up of pure energy. Then the differences in these electromagnetic waves. So the differences so the larger the wavelength, the smaller the frequency. Then the smaller the wavelength, the larger the energy. The smaller the wavelength, the larger the energy. Then the larger the energy, the larger the penetrating power. So the larger the energy, the larger the penetrating power. And as you can see from the sequence, the gamma rays, they have a small wavelength, so that means the gamma rays have a high penetrating power. So the gamma rays have a large penetrating power. Then the other thing that we're going to talk about are the instruments that are used to detect. So instruments used to detect electromagnetic waves. So for the gamma rays, we have the gigamolar counter or tube. Then the X-rays, we have photographic films. Then the ultraviolet, we have the photographic films. Then the infrared, we have the skin. Then the microwaves. The microwaves, we have areas. So the areas and the satellites. Then for the radio waves, we have areas that have a TV or radio set. Then the harmful effects. So the harmful effects of these electromagnetic waves. The first harmful effect is that they cause skin burn. So they cause skin burn. The other harmful effect is that they cause cancer. So they cause cancer. In the other harmful effects that they cause mutation. So we are done on electromagnetic spectrum.